young man named Jeffrey got himself an Apple II Plus, and he said it worked for a while and then it died. So he got onto the Apple II message board on Facebook, started asking around for help trying to get it fixed. So Jeffrey didn't really have the tools or experience to do it. I told him he could send it to me and I would take a look at it for him, and he did, and here it is. So he just sent the important parts. I got a power supply, keyboard, and the main board, and a couple of add-on cards to test for him. So I'm going to open these up from the bubble wrap, take a close look at them, see what we're looking at. Take a look for physical damage first, and then maybe we'll have to get into doing some electrical troubleshooting. There's lots of scotch tape and bubble wrap, so I'm going to see if I can cut through the tape and unwrap these things. I don't want to cut through the bubble wrap because I want to maybe reuse it. So far so good. Okay, let's take a look at the board first. I'm going to get in there with a magnifier. I'm curious about these damaged traces down here. This looks pretty bad. And Jeffrey sent some pictures before. I do remember seeing some additional damage on here, but I'm not seeing it now. I'm going to have to take a close look. There's this one. There was definitely some other problems with traces elsewhere, but I don't see them right now. Oh, here they are. I'm going to take a close look at this stuff right here. So there's probably more than one or two little spots like this. I'll get in there with a magnifier. We'll tone those out and make sure that they're good. Also, Jeffrey, so the first thing I want to do with this board when I'm not actively looking at it or working on it is put it in an anti-static bag to protect it, so we don't have to worry about any ESD. Some people might tell you not to worry about ESD, but I've seen it do damage before, so I do worry about it. So I'm looking at this keyboard connector here, and it looks pretty bad. There's been some really bad soldering on these connectors, and there are definite absolute short circuits, almost certainly cold solder joints that aren't actually making a connection, that could easily have caused damage to this thing and maybe the keyboard interface, I don't know. But I'm definitely seeing some short circuits right here. I'm going to clean that up at some point soon and take a close look at the inside of this thing, make sure. Jeffrey posted some pictures before that showed some of the traces on here were burned. That could easily have been caused by maybe one of these short circuits here on the connector. There's been some work done on the back of the board here as well that looks not too terrible, but not great. And up here. So we'll do some electrical checks on these, clean up the connections where they need to be. So this spot right here on the board is probably not as bad as I thought. This just looks like a spilled bit of solder flux. I don't see any damage under that flux. I'm just going to clean that off. Down here, these traces don't look broken actually. There's a bunch of solder on here. Can't imagine why that's there. I'm going to go ahead and use some solder wick and clean that off. And then we'll check and see if there's continuity on those traces. But right now with the magnifier, they look okay. I'll go through the rest of the board with a magnifier looking for any issues. If I see anything, I'll take a picture. It's kind of stuff that's really hard to tell what's going on from a still photo. I'll do some continuity checks across those connections there. So this trace goes up to here. We have good continuity right there. No problem on that trace. Other trace next to it goes up here. And so this whole trace is good. There's another spot here for some reason with solder on the trace, which doesn't make any sense to me. There's no reason to scrape off that solder mask and just put solder in the middle of a trace like that. I don't know if somebody was just being careless with a soldering iron, or if they were trying to repair a break in the trace just using a solder bridge. Take a look at this trace right here. So Jeffrey, what I got here is something called solder wick. This is kind of like a paper towel for absorbing solder. So if I put this right here, get it hot, rub it a little bit, it'll take off all that excess solder. And there is no break on that trace, so I can't see any reason for solder to be there. I did ring out these other ones down at the bottom of the board as well, and there's full continuity on all of those. I think somebody might have just been soldering near there and were a little careless with their soldering iron. This is probably whoever you bought it from had done repairs on it at some point. Down here, in this area, there's been quite a bit of work done down here, and there's definitely been some soldering done on these through holes right next to this. So I'm going to clean this up and then keep looking around for any other issues. Just using solder wick to clean up the solder here. Kind of ended up spreading it around, but I gotta get all this excess solder off of here. The traces actually look like they're in good shape. No shorts and no breaks. But somebody probably accidentally ended up scrubbing off the solder mask here and then getting a lot of solder on this. This was probably whoever Jeffrey bought this system from had done repairs in the past. It should be clear, all of these traces have good continuity, no shorts and no breaks, so this is probably not what was causing the problem. Now that the solder's cleaned up here, I'm checking for shorts just by seeing if we get a beep when I connect between these. So that's the same trace, that's the trace next to it, there's no short there. And the trace next to that, no shorts. So we have good continuity all the way through there and there and there. So no shorts, good continuity. I'm going to clean up these pads. I think what's happened is somebody was replacing something and they had soldered on these. There was a lot of excess solder on these pads, and I think it just spilled over to the ones next to it. So here's that area of the board all cleaned up. Definitely no breaks and no shorts. And everything in that area looks fine now. There's another spot right there. That was never much of a problem. And then this spot up here, focus, looks fine. I'm going to clean that flux up. I haven't cleaned that area yet, but there's no break there and no short circuit. So there, that looks a lot better. So there's a lot of most types of flux are labeled as no clean, so you don't actually have to clean them off, but I got in the habit of cleaning them because there are some types of flux that are corrosive, and for the most part it just looks a lot better when somebody else comes behind you to do more work. It's kind of hard to do this kind of work on camera, but just for the sake of Jeffrey to learn how to do this. This is isopropyl alcohol, so I'm just dipping a Q-tip in there, and then I'm just rubbing the area to get the flux off. So the problem with using a Q-tip on a board like this is that these pins will shred it and leave behind cotton. So once the alcohol dries off, I will take a close look and go back and pull off the bits of shredded cotton. Sometimes I'll use a toothbrush, but that doesn't actually absorb the alcohol off of it, and it just kind of spreads around the flux that you're trying to clean off. So apart from those couple of areas that I just concentrated on, which were actually fine, there were no shorts or no breaks in continuity, so those were not the problem. And I've literally looked at every single other pin and through hole. I'm looking for cold or cracked or broken solder joints, any kind of short circuit, any kind of break or damage that looks like it's not supposed to be there, and I don't see anything. The back of this board looks perfectly fine. I'm going to flip it over now and take a really close look at the top of the board. So likewise with the top side of the board, I have looked it over very thoroughly. I don't see any problems with traces or components on the top side of the board. There does appear to be one RAM chip missing, although this socket is white, so I'll have to do some research on that and find out if that's even supposed to be there. The other white sockets are for optional connectors, but this is labeled RAM. None of the chips appear to be inserted backwards. Everything looks perfectly fine on the top side of the board. I'll do some research, make sure that all the chips are where they're supposed to be. And looks like we're going to have to break out the oscilloscope and start doing some of the hard troubleshooting. Well, Jeffrey did his best to repair this broken wire here, but this blob of solder is going to have to come off. We'll do it proper with some heat shrink tubing to keep it insulated so that it doesn't short out. See if my iron's hot enough to melt this yet. It's definitely pretty hot. This blob of solder is going to take a few seconds to heat up. Okay. So ideally you wouldn't want to cut too much of this wire off, but I think this is going to be okay because this connector just loops around pretty quickly anyway. Let's see, is this 14 gauge? Strippers cut through it, but the plastic's melted onto the wire. That's good. So there's a couple of good ends to put back together, and I'm going to put some heat shrink tubing on here so we can shrink that over the connection when we're done. Don't quite know if I'm going to be able to do a lineman splice here, but I'll try to twist those together a little bit. I don't have a lot of room to make this a lot bigger because I need to fit that heat shrink tubing on. This is the only size I have available. Now that they're joined together, a little trimming of any sharp edges on there. Put the heat shrink tubing over that. And fire up the heat gun. The heat shrink tubing shrinks up around there. Seals that up. And we'll plug it in and check the voltages. Let's take a look inside the power supply. There's some screws missing on either side, so somebody's been in here before. So here's the inside of the power supply. Doesn't look terrible. The paint seals on the screws, some of them look like they've definitely been removed before, but like that one doesn't look like it's ever been removed. This has the original reefer cap in there, so I'm going to go ahead and pull that out for Jeffrey. I actually have a replacement, so I can put that replacement in there. But the rest of the power supply seems to look okay. So Jeffrey, I'm going to go ahead and take that capacitor out because just eyeballing it here from this angle, it looks like the original capacitor, 30 some odd years old. And those capacitors are well known for bursting, short-circuiting, and or spewing out some nasty smelling smoke when they get old enough to do so. I replaced the one in my power supply recently and happen to have an extra one on hand, even though you honestly really don't need them. The power supply will work fine without them. They're there for FCC compliance. So pull that connector off there and twist that connector off there. There's a power supply. The original that I pulled out of my power supply looks like this, and I can see the cracks in it here. The replacement that I bought looks like this, the modern made replacement. Jeffrey's definitely appears to be original. There's definitely never been any soldering done on the bottom of this board, and that's the original style of translucent yellow plastic. There's the old capacitor. Clean up these holes. And the new one. There. And we have one less thing to worry about. Looks like there was some missing screws. Not sure why. Yep. Look back at the video, I only took out 5 screws. So I'm going to make sure the 4 corners are done, and then only have one screw in the center part of it. I'll apologize in advance for the camera angles and the audio quality. This is a rough and dirty video, so these are going to be pretty informal as I go, and probably not a lot of editing, so I don't have to spend too much time. Put back. If I can get all of these little bendy bits in the same place they were. which is always a bit of a pain. Squeeze it, push. There we go. Some of these felt a little stripped out when I took it apart. They weren't very tight. That one felt okay. That's stripped out. Get this. We're short on screws, so I'll avoid putting them in the holes that are stripped out. 3 on this side. Put 3 on the other side. And that is all we got. So, I think the eBay seller you bought this from probably lost some screws when he was working on it. All feels okay. Alright, let's check the voltages and see what they look like. So, it's time to check some voltages. Got the power supply plugged in. Go ahead and turn it on. Put my negative lead on the ground pin. And we'll check here where we should have 5 volts. We have 5.5. That's probably intolerance. Should have 12 here. We have 13. A little high again. Negative 12 is 11.9. That's pretty darn close. Negative 5 is 5.1. So the 12 volts and the 5 volts are both a little bit high. Probably not enough to worry about. Well, I went through chip by chip. Fortunately, the board layout here has all the chips labeled, so you know exactly what type of chips it's supposed to be in each socket. And I'm satisfied at the moment that all the chips are where they're supposed to be and oriented correctly. So, let's plug in the composite video and the power supply and just take a quick look and see what we get on the screen. I also want to check the voltages with the system under load. I have a picture. It is hard to see here, but it is all question marks. Every block on the screen is a question mark. Can't really turn. The brightness is actually pretty low, it seems, but it's all question marks. So, I'm going to check the voltages if I can with the system under load. So, double check the orientation. If I'm not mistaken, towards the edge of the board is the ground. And that makes sense. Those are connected to the ground plane. So, I'll go ahead and turn it on. Get on here and we'll check here. 4.9 volts under load. 12 volts under load. Negative 12.2. Negative 5.2. So even though these voltages looked a little high when the power supply wasn't loaded, they look just right with the system under load. Still nothing but question marks on the screen. So I'm satisfied for the moment. There's nothing physically wrong with the circuit board itself or the power supply. So we're going to have to start hunting for a bad chip. That is going to be the hard part. If anybody sees anything on the board that I missed, let me know in the comments or in the Facebook group post. As far as I can tell, everything looks like it should here on the front. And everything looks fine here on the back of the board. I'll get out the oscilloscope and do some more troubleshooting on it tomorrow. Before I move on to the electrical troubleshooting, I'm going to finish up with the physical stuff, and this looks really bad. This is a mess back here. So I'm going to clean this up, fix that solder job there. I'm going to take the keys off and look for any problems with the circuit board underneath here. Looking at the board here, this pad here, there's 2 copper pads here, 2 copper pads here, and there should be 2 copper pads here and here, but definitely burned up when something short-circuited. Put some clippy leads on here so I don't have to balance it. And we are getting a measurable resistance and continuity, so it looks like that bulb is actually good. There is such a thing as too much solder. So much solder on some of these that it's causing short circuits between the pins. So on a side note, it helps to have one of these head-mounted magnifier, especially when you're my age and your eyes start to go on you. There we go. Don't want to spill that. That looks much better. The pad's missing from here, but I don't think that there's a trace that's supposed to connect to that. I'll have to examine that closely there. These are numbered pin 1 through 25, and the pad is lifted off of pin 1. I don't know if it's supposed to be connected here or someplace else. So I'm going to check the schematic for that, see if that's supposed to be connected anywhere. Because right now it's not going anywhere. So these globs of solder on the pins right here, I'm going to try to clean those off, but I don't know if I'm going to be able to do it on camera. So that wasn't as bad as I thought. I got the solder off of there pretty easily. So those pins will go into the connector smoothly now. Just enough solder to make a solid connection. No more and no less. Too little solder, you get a cold solder joint, which means there's no actual connection or no reliable connection. The solder can crack when it's flexed slightly. And too much solder, of course, you'll end up shorting out to the pin next to you. Am I getting this on camera? Don't want to linger too long on these pads or these pins. The pin gets too hot, it'll end up melting the plastic on the connector. So that looks much better. I'm going to clean the flux off, and then I've got to take a look at the schematic and see what to do about pin 1. There, much better than it was, nice and clean. And if we look, connector pushes through nice and easy. No problem. And just a quick note, that's going to be it for today. It's getting late here. Tomorrow I might break out the oscilloscope and start checking chips, but I'm going to have to do some studying first to find out what kind of signals I should expect to see on some of those chips. So I need to find schematics, maybe print some of them out so I can have something to reference. Anyway, I might put this up tomorrow or early tomorrow morning, and it'll be probably another day or two before I do any more video showing any of the oscilloscope testing.